All right, so let's work another example of doing some signal operations. This one will be a little bit more challenging though, because we're actually going to do some combined operations. So the signal that we're going to work with in this signal, again, we'll call it x of t. And in this example, the signal x of t looks like this. So a triangle, a rectangle, essentially. So that's the signal x of t. And what we're going to do is we are going to sketch the signal y of t, which is equal to x of 2t plus 3. So we can tell that there's some shifting going on, and there's also some type of compression or expansion. We're actually going to do this two different ways. In each way that we do it, each approach will end up getting the desired signal, x of 2t plus 3. We'll just order the combined operations in different ways, and we'll show how you need to be careful in how you do the operations. So approach number one, I'm going to think about starting with my signal x of t, and I know there's two operations going on here. There is an expansion compression type operation, and there's also a shifting. So the first thing I'm going to do in this approach is I'm going to go ahead and do the time shift. So I'm going to go from x of t to x of t plus 3, which is a time shift, and that's a time shift of 3 units to the left. We know when we do a time shift, that means replace t with the amount of the shift. So we replace t with t plus 3. After I've done the time shift, the next operation is a time scaling. In this case, it's compression. When we compress, we replace t's with at. So in this case, we wanted to get to 2t, so I've replaced the t right here with 2t. So we can think of these operations as a time shift by 3 and then a time compress by a factor of 2. So let's go ahead and sketch what this is and then sketch what this is to get this final plot that we want. So the first thing I'm going to do is do my time shift. I know that t plus 3 means shift 3 units to the left, so my original figure, when I sketch it right here, is going to look exactly the same, just everything has been shifted 3 units to the left. So minus 2 turns into minus 5, 0 turns into minus 3, 4 is going to turn into 1, because 4 minus 3 is 1, etc. So this part's pretty easy. My original signal looks exactly the same, I've just shifted 3 units to the left. So I've gotten to here. This is now the signal x of t plus 3. Alright, now I need to go ahead and do my time compression. I need to compress everything on the time axis by a factor of 2. So the easiest way to do that is just to look at all these values and divide by 2. So originally, in this signal I was at minus 5, so this edge will now occur at minus 5 halves. I used to go to 0 here at minus 3. That's now going to occur at minus 3 halves. This edge used to be at minus 1. That will now occur at minus 1 half. This edge used to occur at 1. That will now occur at 1 half, etc. So I can just redraw my time axis and do exactly what I just said. Everything's been squished in time by a factor of 2. So this is the final signal I was wanting, x of 2t plus 3. And we got this signal by doing time operations. We did a time shift, and then we did a time scale. All right, let's do it the other way. Let's do a time scale and then a time shift. That's another way to do this problem. So I'm going to start with x of t, and then the first thing I'm going to do is I'm going to do a time scale. We know that we need to scale by a factor of 2, so I have replaced t with 2t, so I've done a time scale. The next thing I need to do is get this shift in there. Here's where I need to be kind of careful though. When I do my time shift, I want my final overall shift to look like 2t plus 3. If I was to replace t with t plus 3, I would end up with 2 times the quantity t plus 3, which if you multiply that out, you get 2t plus 6, which is not what I want. I want to get to 2t plus 3. What I need to do is I need to replace t with t plus 3 halves, so when I multiply this out, I do indeed get 2t plus 3. So the amount of the time shift that I do in this approach is actually a shift of 3 halves. It's a completely different shift if I want to get to the final signal x of 2t plus 3. So this is why in the lecture I was saying order matters. How you do these things, there are different ways to get to x of 2t plus 3, and you just have to be careful on how you do it. Remember, time shifts mean replace t with a new quantity. In this case, we had to replace it with the quantity t plus 3 halves, and then when you distribute the 2, you get the 2t plus 3 just like you want. Alright, so let's go ahead and sketch these individual pieces. Just recall what x of t looks like. This was our original signal x of t. In this approach, the first thing I'm going to do is do a time scale. I'm going to compress by a factor of 2. So we look at this time axis and we divide all these values by 2. So what used to happen at -2 now happens at -1. What happens at 2 now happens at 1. What happened at 4 now happens at 2. Everything gets compressed by a factor of 2. So that's my signal x of 2t. Now what do I need to do? Now I need to take this signal x of 2t and I need to shift it 3/2. And I need to shift it 3/2 to the left because this was a t plus 3/2. So if I take this signal and shift it 3/2 units to the left, I get the signal that we got in the first approach, which is what we should get. We're trying to sketch the exact same thing. So -1 shifted 3/2 to the left is -2.5, so that's why that edge is right there. The 0, where I hit 0, that's now going to happen at -1.5. 2 minus 1.5 is 1/2, so this front edge is now at 1/2, etc. So we get the exact same answer, like we should, because we're sketching the exact same thing. We just did it with slightly different order of operations, and we took care to make sure we put in the right shift to yield the final expression that we needed.